In this video, we're going to talk about the law of cosines. We already know from our previous studies about the law of sines that we can use the law of sines to solve a triangle if we are given two angles and a side of a triangle. Or we can use the law of sines if we're given the length of two sides and an angle across from one of those two sides. In all other situations, we would have to use the law of cosines. We can use the law of cosines to solve a triangle if we know the length of two sides and an angle between them, or if we know the length of all three sides. Below, we see all the different versions of the law of cosines. Now, don't get too concerned about this. I know this looks like a lot to remember, but just remember that all of the versions that you see on the left side here, they're all generally the same thing. And the ones that you see on the right side over here, they're all generally the same thing as well. The only difference is we use the formulas on the left when we're looking for the lengths of the sides of a triangle, and we use the formulas on the right when we're looking for the measurements of the angles in a triangle. The formulas on the right are the same as the formulas on the left, except they're just solved for, in this case, cosine of A, in this case, cosine of B, and in this case, cosine of C. One thing that's really cool about the law of cosines is that it's just like an expanded version of the Pythagorean theorem. For instance, let's take this triangle, A, B, C. We can plainly tell that this triangle is a right triangle. And let's say we want to solve for C. We want to find the length of side C in this triangle. Well, we would use this formula. This entire portion of the formula is going to be equal to 0. Here's how I know. Cosine of angle C is a 90-degree angle. Cosine of 90 is 0. 0 times negative 2ab is just 0. So in the case of a right triangle, what are we left with? We're left with just c squared equals a squared plus b squared, which is the Pythagorean theorem.